So this is chapter 7 from the textbook, and it is the last part of your CO4 that is about probability. That is an important topic, okay? And especially for computer science students, this is very much important because if some student wants to do MS and PhD in future, then this is the area you must have skills in that. Otherwise, it would be difficult for you to do your thesis because mostly students that normally they develop some kind of model in their thesis, and mostly models are probabilistic, statistical. You should have to apply some probabilistic model over them. For example, maybe you have heard the naive Bayes theorem, the neural network, the deep learning. You maybe heard these terms. All these are probabilities. All these are probabilistic models. But here we are going to build our foundation. So that's why this is an important topic. So normally the probability theory in computer science, it is written here that we normally use this theory uh, for calculating the complexity of algorithm. But this is one direction. This is one direction. As compared to this textbooks, it's okay. You can apply this theory to calculate different things. The common popular examples are weather forecasting. For example, you are hearing that after 2 days, this event can happen. So this is probability theory by looking at some historic data. Anyhow, so now the first definition that we have here is about the finite probabilities. This is the first definition. What is finite probability? Okay, the word finite is okay. Something is finite. Something has a limit. Okay. Whenever there is the word probability, then you should have to consider two things in your mind. The first is the space, the total space in which different events can occur. In which different events can occur. First is the space, or you can say the problem space area, you can say. We will represent that space with S. And the second thing that you should have to keep in your mind is the events that will occur in that space. And we will represent those events with E. So S is what? S is a finite, non-empty. It will not be empty. It will contain some events, some outcomes. And all those outcomes or events should be equally likely. What it means? You will see this word again and again in the definition of probability. Equally likely. For example, if there is a space and there are 10 events in it, then each event, if I say is equally likely, then it means that the probability of each event is 1 over 10. 1 over 10. This is the simple formula. Each event has equal chance to appear from that space. Each event has equal chance to happen from that space. So two things you have to keep in your mind: the space and the event. And what is finite probability? This is the equation. Probability of event, any event. Okay, here E means any event because this is a definition. Any event which is in that space, any event which is in that space S. So what would be the probability? The equation is the size of the event, cardinality, the other name is cardinality, size of event, or you can say the value of the event. For understanding, you can say the value. The size of the event divided by the size of the space. For example, here, the size of the space is 10. And if any event, you are talking about 7th event, that is 1 event. So the size of that event is 1. So then you can say 1 over 10. So this is the simple definition for finite probability. But now here it is an example. Equation is simple. And we will see different kinds of probabilities with the passage of time. When we will go through these slides, we will see different definitions. So now this is the example. And the question is, what is the probability that the two dice, you know that, I don't know, Ludo, you have the name word, Ludo, and you normally use some dice in the Ludo. Anyhow, so what is the probability when two dice are rolled and the sum of the numbers on the two dice is 7? So you have two dice and you just roll them, and the sum of the two dice, you will have some number on one dice, some number on another dice. The sum of the, when you will do the sum, it would become 7. So what is the probability that you will roll the two dice and the sum of the two numbers would be 7? So now the question is like that. So it is a simple question. So here in these situations, what you can do, you can use the product rule. What are the total number? What is the size of the space of dice 1? What is the size of the space of dice 2? 6 is the space. 6 is the size of the dice 1. 6 is the dice of size of the dice 2. So product rule, multiply them. 6 multiplied by 6, 36. So total size of the space is now 36. Total size of the space is now 36. Or you can say total number of events in that space is 36. But what is the question? The sum of the numbers on the two dice is 7. How it is possible? For example, it can come that 1 here, 6 here, 2 here, 5 here, 3 here, 4 here, 4 here, 3 here, 5 here, 2 here, 6 here, 1 here. These are the all possibilities which can give you the 7, which is written here. These are all possibilities. 1, 6, which will give you the sum 7. And how many these are? What is the number of these events? 1, 2, 3, 6 events. 6 events. These are the events which we want, for which we want to calculate the probability. Total number 36 is the total number of events available in the space after applying the product rule. After applying the product rule, 6 square is equal to 36. And then you have to count the outcomes, events, successful outcomes, not total outcome. Outcomes and events, okay, you can take it as same. In one event, more than one outcomes can occur, but keep this definition aside. Okay? If the question will say that you have many outcomes in one event, then we will consider them. Otherwise, for now, outcomes and events is the same thing. Okay? So these are the 6 outcomes which are successful, because their sum is 7. So now what? Total is 36. Apply this equation, and then you have your answer. This E is successful event. This S is the total space which is containing the total number of events. So 6 divided by 36, what you will have? 1 over 6. That is the probability of that the two dice will come up with sum 7 when you roll them. What it means that at least 6 times you will roll the two dice, then there is a chance that you will get the sum 7 one time. What it means. Okay. So if somebody is ignorant, then you can do the bet with them. Then you can do the bet with them if you have a belief on probability theory. Sometime you will lose, but just keep a belief. Now, example 16. What is the probability that the numbers 11, 4, 70? Should I started the recording or not yet? Yes, alhamdulillah. What is the probability that the numbers 11, 4, 17, 39, and 23, these are the 5 numbers, are drawn in that order, are drawn in some tartib from a bin? You have some basket from which you have to take out the numbers, and that bin containing 50 balls labeled with 1, 2, and so on 50. So you have a basket, and in that basket or bin you have 50 balls, and all balls are labeled from 1 to 50. What is the question is, what is the probability that you will get the balls with these numbers? You will get the balls with these numbers. But so this is one question, but here for the question you have 2 parts, A and B. The question is you have to calculate the probability for these 5 balls, but there is some scene, there is some situation. What is that situation? The part A, the ball selected is not returned to the bin before the next ball is selected. So this is part A. In this part, when you have the 50 balls, you will select and see what is the number. Okay. If it is successful or not, keep it out. And then now you have the 49 balls. Then select, and you don't have to return it back until you select all these 5. And then, okay, what is that? That number required or not? Okay, keep here. And what is that left? 48. Keep it. Successful or not? Keep it here. What is left? 47. So you have, when you will draw first, it is 50. So by the product rule again, you have to calculate the total number of space. What are the total number of outcomes possible with respect to this 50 balls? 50 is the ball, but number have the options. You have to, so first time you have 50, 49, then 48, 47, 48. When you will multiply them, these are the different ways. So this order is mattered. It is not, this order is matter. You have to take out these balls in this tartib, in this order. 11 first, 4 after, 17, and then 39 and 23. If order is disturbed, then it is not required. Put them back. So I will tell you that here there is a little bit ambiguous sentence, so that's why I have given you the clear meaning. You have to take it out and keep it here. And for the B, you have the different option. The B is saying the ball selected is returned to the bin before the next ball is selected. So this is the second question. You have to calculate the probability with this case, and then you have to calculate the probability with in case of B. And what is B saying? That if there are 50 balls, you will select them, you will see, and then you have to return. Then you will take out, you will see successful or not, and then you have to give it back to that bin or whatever. So it means that the 50 balls will always remain there. So that is the second question. So now calculate the probability. So for the first case, when you don't have to put it back into the bin, then this is the situation. So you have to apply the product rule because we have to take care of this order. So that's why due to this order, we are multiplying and then we are seeing that these are the total number of combinations which are possible. This is a large number. So after multiplying, then you will get this one. These are the possibilities that you can select the ball. These are the different ways to select the balls. Because, why? Because when you will take the first ball, then 49 will remain. When you will take out that one, then 48 will remain. So each time a ball is drawn, there is one fewer ball. Anyhow, moving forward. So these are the total number of ways. Now, how many balls you have to? And if these balls 11, 4, 17, 39, 23, if they are, the probability for the selection is equally likely, 50 balls. Then what? These are the 5 balls. So, and when you will select some ball, okay, that in the 50 balls, each ball has 1/50 probability. In the 50 balls, each ball has what? 1/50. But we have to keep the order. So due to that order, this we applied the product rule and we have calculated the different number of options. Like in the dice, you have the 6 options. In the other dice, you have the 6 options. You multiplied them. You have 36 total options. Similarly, you multiplied them and then you have this total number of options available for selection of balls. And from those, you have to select one ball. So 1/that, this is the probability in case of A. In case of A. So this is called the other name. Oh, anyhow, this is the answer. And this technique is also called sampling without replacement. Sampling without replacement. You are taking it out and not replacing it again. And then for the B, so 50 is the total ball. 50 is the total number of balls. And each time, how many times you will select the ball? 5 times, because you need 5 balls. So then each time you have the 50 balls. So that's why 50 raised power 5, you have these total number of options available to select the ball. For case B, when you don't have to put back the, when you have to put back the ball in the bin. And then what? Okay, and when you will select, and each ball has equally likely, so that's why 1/all number of options. That is the probability for one ball each time you are selecting. And this is the other name for this is sampling with replacement, because you take out the ball and then you replace it again there, or you can say you keep it back there. Okay, moving next. Now you have the definition of probability of an event. Probability of E, the probability of an event. Now this you can say this is a definition, but it's theorem and also you can say the definition. We are going to see something, probabilities of complements of event. If you have the event, what is the meaning of the complement? The opposite. The opposite, okay? The complement means the opposite. If E is your normal event that we have seen so far. Then what is the complement of E? The opposite. For example, you have the space with 10 events and you want to see the probability of event number 7. So that is E. 7 number is E. And all other events are the complement of that number 7 event. All other events 1, 2, 3, 4, 5, 6, leave 7, 8, 9, 10. So these are the complements. Okay, these are the complements of that event. Anyhow, now moving forward. If E is an event and S is a space, then we can write the complement of event or E bar. How it means? Total space, total size of the space, minus event, that number 7, you have to subtract that from 10. And then you will have that complement. And now the equation will become, the probability equation will become probability of E complement or E bar. Normally, the value of the probability normally remains between 0 to 1. So the maximum probability is always, the maximum value for the probability is 1. Is 1. Whenever you will get some value for the probability in your any course, that would be between 0 and 1. Okay? That would be between 0 and 1. If that would be 1.2 something, that is something wrong with the data. So it would be between 0 and 1. So the maximum value for the probability is 1 and the minimum is 0. So here, if you will see, the probability of E complement is equal to 1. So that is the total space. When the all events are, you can say, active, you can say. That is the total probability of the space. And from that probability, if you will subtract the probability of that event E, whatever the probability will remain, that would be the probability of the complement, not the probability of E, because you are subtracting the probability of E. You are subtracting the probability of E. For example, if 0, 0.1, 0.2, 0.3, and so on, up to 1, and 0.7, and 0.7 is something, the event. So from 1, you can say from 1 if the probability of that is not okay example, because then you will confuse the values. Anyhow, 1 is the total probability of that maximum can be possible. You can consider it as a space, okay? And from that space, you have to subtract the probability of subnormal event, not complement. And then what you will left with, that will be the probability of the complement, the opposite. You will see here. This is a simple proof. This is a simple proof to find the probability of event E complement. We know that according to this theorem 1, we know that according to the definition, you can say, what is E complement? Space minus E. Space minus event. What you will get? You will get the complement of E, the opposite of this E. Okay, this is written here according to that one. And if you will put bars, these bars, which means the cardinality of or the size of E complement, this is equal to that one. Size of E complement is equal to size of the space and size of the event. You can consider whenever these pipelines is here, it means that you have to give the value. So this or that thing, it's the same thing. It's the same thing. Now we are going to start this. We are going to make this equation again for a proof with this simple definition, from this definition, which is E divided by S. This is the normal definition. So probability of E complement, how can I write that? According to that definition, probability of E is E divided by S. So by using that, and probability of E bar is what? You can say probability of E bar given S. And what is probability of E bar? S minus E, or like that. So can I write that total space minus normal event divided by S? And this is what? This is E bar. So it is, so this is E bar. So probability of E bar is equal to, I can say probability of E bar you are not seeing any, oh, okay. What I want to say that probability of E bar is equal to, first I can write like that according to the previous first definition. According to that definition, this one. Okay. But this one, this E bar, I know that this is what? Probability of our E bar is equal to S minus E. This is what? So now I can write it like, I can directly write it like that. But for example, according to that proof, I am writing it for the what is E S minus cardinality of S minus cardinality of E divided by or given. It means given, okay? Or you can say divided by whatever it, whatever or wherever you feel better. And then cardinality of the space. So this is written according to that equation, nothing else. And if you will simplify it, S divided by S, it 1, and then E bar, then minus, and E bar, E divided by S. So after simplifying it, you have this situation. And after that, E divided by S is what? This is that equation, probability of E. So replace it. Replace that portion with the earlier definition. And then you have 1 minus P. So now you can see probability of E complement is 1, which is the probability of the whole space. Maximum probability. You can say maximum probability. And then you are subtracting the probability of normal event from it. And then what is left? The E complement. So that is the proof that probability of E complement is equal to 1 minus PE, which is the equation here. And now we have the example for this theorem. These are, by the way, interesting topics, which needs your full attention. But these are the simple questions. It will become complex if you will move forward. So a sequence of 10 bits. So you have 10 bits, okay? You have 10 bits. And bits can be 0 or 1. You know that. A sequence of 10 bits is randomly generated. So that sequence of 10 bits will be generated randomly. What is the probability that at least one of these bits is 0? 10 bits randomly will be generated. And you know that bits can be 0 and 1. And the question is, what is the probability that at least one of these bits, and when the 10 bits are completed, what is the probability that at least one of those bits or these bits is 0? Is 0. Now, the question that will start, you have to For every question, not this one. Whenever the probability asked, then the event will be given to you, the space will be, information about the space will be given to you. So your first duty is to identify the event and the space. And then you can move on if you have, for example, for the previous topic, we know that we have that equation and we can apply the product rule. So that is sufficient for that. But here we will go in a different direction. So the first duty is to identify the what is event. Event is that for which we want to calculate the probability. What is the probability that at least one of these bits is zero? So your E is what? E be the event that at least one of the 10 bits is zero. So this is E. This is E. When one of the 10 bits is zero. We are in the topic of this one, E and E complement. And what is the complement of this E? Just because this theorem will give you the answer of this question easily, otherwise it would be an issue. If you will calculate it like previous approach, single entry, then you have to consider that it can be zero, it can be one, or like that. What is the complement of that event? Complement. At least one bit is zero in 10 bits, that is event. And when you don't have any zeros, that is the opposite. When you don't have any zero in the 10 bits, that is the opposite. That it means that all are ones. So what is complement? That all bits are ones. There is no at least one zero in 10 bits. All are one. So that is complement. That is complement. We want to use this equation, okay, to get the answer for this example. And what is the sample space? All bits strings of length 10. We are not saying 0 or 1. All bits string with length 10. So this is the sample space. So now, according to that theorem or equation, what we have to do, we have to calculate the probability of E. And what is probability of E according to previous knowledge, not E complement? Probability of E is what? With this equation, you can move this E here and complement here, no issue. You can move left and right. You can calculate the probability of E and you can calculate the probability of E complement with this equation. No issue. So here the probability of E, the normal event, would be what? You will move the complement here. You will subtract the complement here from 1. You will subtract the opposite. Okay, that's okay. Then 1 minus, and what is the equation for complement? This is E bar given as, I can write it as, yes, okay, no issue. I can write this equation by using that equation, okay? Nothing else. I told you already here. No issue with that one. And then what? 1 minus, what is E complement? When you have all bits 1s. When you have all bits 1, when you have all bits 1, that is, the probability is 1. You don't have any chance for that. All bits 1. And what is the total space? Each bit can be 0 and 1. So 2 raised power 10, which is the number of bits. 2 raised power 10, which is the number of bits. Total bits are 10. And each bit have 2 possibilities. To 2 raised power 10. So this is, you can say, the product rule. 50 multiplied by 5, you have seen previously. Anyhow, so 2 raised power 10. Now calculate it. 1, and you have 103, 104. If you can simplify it further, it's okay. If not, no issue. So this is probability of E is now finally, this is the value. So this is the probability that you will get at least 1 bit in 10 bits. And from this equation, you are calculating it easily. Otherwise, it would be an issue for you to calculate this. Now, another topic. Probabilities. How many topics we have seen here? First, the finite probability. Then, the probabilities of complements of events. And now, probabilities of union of events. When you want to calculate the probability of more than one events in a space. When you want to calculate the probability of more than one events in a space into the form of a union. So the statement of the theorem is, suppose that if you have E1 and E2 are the events in the space, then this theorem normally says that you can calculate the probability of the union of those two events, E1 and E2 union, the probability is equal to probability of E1 individually plus probability of E2 individually. You have to sum up, and then you have to subtract the intersection of these two events. The probability value which you will get by intersecting them. So the probability of their intersection, you have to subtract that. So that is the equation. I don't know, maybe in section 2.2, when we were in CO1 or CO2, when we were seeing the union of two sets. Union of two sets is simple. Union of two sets is simple. But at least it is equal to that one, this portion, not with subtraction. Okay? Anyhow, this is the theorem. And this is the equation of this theorem. You have to keep that equation in your mind if you want to calculate the probability of union of events. So you have to calculate the probability of events individually, and then you have to subtract something from that, and then you will get. So you can write it like that. This is according to previous knowledge, okay? He's referring back to section 2.2 where the sets are, and then you will have something like that. Or you can simply say union of two events, the size of union of two events is equal to size of E1 plus size of E2 minus their intersection, size of their intersection. Okay, keep it as an information. Now, we want to build that equation. We want to build that equation. How? Probability of E1 union E2. This is the left-hand side of this equation for the theorem. How you normally write a equation for the probability simply, that is the standard definition. Probability of E is equal to E given S, or E divided S. So now, according to that equation, this is now your E which you are writing here, and this is the given space. So probability of E is equal to size, cardinality of E given space. So we are writing the same. We are using that standard definition and writing this thing like that. Nothing else. And then what? E1 union E2. Now we are using E1 union E2 to expand this one. We are using this fact which is available in chapter section 2.2. Okay. And we can write this thing which is equal to that one. And here you are writing size of E1 plus size of E2 and their subtraction and the subtraction of the intersection and given space. Here, I am saying it given, okay? Because this division means given. That space is given to you. You have to find the probability of some event. So that's why I'm using given. And then what? Okay, simplify it. Break it into units. E1 given S1, E1 given, or you can say E2 divided by S, and then this one. So just break it or simplify it. And now what is this one according to the definition of your first finite probability? E1, size of E1 given S. This is the probability of E1. This is the equation. So that's why you are writing it probability of E1. This is equal to probability of E2. And this is equal to, leave this minus, only that portion. This is equal to probability of E1 intersection E2. So this we are reaching at the right hand side of this equation. So this is the proof. You started with left hand side and you have reached at the right hand side by using some earlier facts. Now the example of this theorem is here. What is the probability that a positive integer selected at random from a set of positive integers? You have a set of positive integers starting from 0, 1, 2, 3, 4, and so on. You have a set. You have to select some positive, you have to select some number from it. That is a set of positive integers. So you will select positive. So you have to select positive number from that set randomly. I'm not, so what is the probability that a positive integer selected at random, randomly select from the set of positive integers not exceeding 100? And when you will select, that number will not exceed 100. The set is infinite. The set is something infinite. You can, or you can say finite, okay, maybe up to 1 lakh or 0.1 million or 2 million. And then you have to select, some positive number from that set, not exceeding, a set of positive integers not exceeding 100. So now limit is given to you. You are not going to infinity. You are just selecting from maybe 0 to 100. The condition is given to you. And then from 0 to 100, you have to select numbers. And then what is the probability that random number that will be selected would be divisible by either 2 or 5? Would be divisible. So the number that you will select from that set of positive integers not exceeding 100, what is the probability that the number that you will select would be divisible by 2 or by 5? So basically you have to calculate two events, numbers which are divisible by 2 and numbers which are divisible by 5. And then you will have, then you can sum up by using that equation. You have even 1, you have even 2. So you have to calculate even 1, you have to calculate probability for even 2, and then you have to calculate their intersection, their probability, and then when you will calculate finally, you will have that. So this is basically 2 events. So the numbers that would be divisible by either 2 or 5. So if you will select some number that would be divisible by 2, some numbers will be divisible by 5, some number will be divisible by both 2 and 5, because we have a OR. So you have to think in that way. You have to think in that way. If this equation is in your mind, then you will think automatically and with the practice. So here you have 2 events. So you have to calculate this one, E1, E2, and then their intersection. So what is here? I am saying, what is E1? E1 is an event in which the integer selected, the number selected at random, would be divisible by 2. And E2 would be event with divisible by 5. And E1 union E2, we want to calculate their union. E1 union E2, if you say, so when you will take union, then this would be the event in which you will have the number that would be divisible by 2 or 5. 2 or 5 both. What would be the definition for E1 union 2? That would be the event in which you have the numbers that would be divisible by both 2 and 5. So you are just representing it. So this is what you want to calculate. And you know the right hand side. And what is E1 intersection E2? We are just explaining. Otherwise, this is the answer. This is just illustration. This is just understanding. Otherwise, this is the answer. If you will write it, that is okay. Okay. But this is the understanding. But this is the understanding. What is E1 intersection E2? You will have the event in which you have the number intersection that would be divisible by 2 and also 5 and also 5. For example, 0 to 100, if you have the number 10, that would be divisible by 2 and also 5. If you have 20, divisible by 2, divisible by 5. Both 30 to 5. 40, you can go on. So there are 10 numbers in from 0 to 100 which are divisible by both 2 and 5. 10 numbers. And from 1 to or 0 to 100 numbers. From those 100 numbers, how many numbers which are divisible by 2? Half of them, because they are even and odd. So E1 is how many numbers? 50. E2 is what? Divisible by 5. Divisible 100 divided by 5, you will get 20. So 20 numbers from 0 to 100 are those numbers which are divisible by 5. So this is your size of E1, size of E2. This is not probability. This is size. Total number of events related to that category. And then E intersection E2, which are divisible by both 2 and 5, there are only 10. I told you earlier. There are only 10. Now you can put these values in the equation and you have your answer. So the equation is probability of E1 union E2 and is equal to, this is the equation. Probability of E1, probability of E2, and that's their subtraction. And what is the probability? E1, total number of events are 100. Total space, size of the space is 100. So E1 is 50. 50 divided by 100. Now, whatever you will get, that would be probability. That would be probability. Similarly, probability of E2. What is the number of E2? 20. 20 divided by 100. In the equation, you will have 20. And similarly, intersection, 10 by 100. And after evaluation, you will have 3 divided by 5. So now that is the probability for which the question was asked. So what is the probability that the number that you will select would be divisible by either 2 and 5? So that is the number. This is the probability. You have the actual count and then you have to divide it with the total number of counts that you have the probability. For example, in your mobile phones, I don't want to give you this example, but just for fun, in your mobile phones, you have the prediction system. If you will make it on, when you will type one word, the next word will be predicted automatically to you. After writing or after typing one word, the next word is predicted. That is called bigram. Sometimes some software will work if you will type one word, and if you will type the second word, then the next word will be given to you. That is called trigram. trigram means 3 words, bigram means 2 words. How this model works? Take a text file in which you have the text. If you want to implement a bigram model, then you have to take 2 words. You can start with from the beginning of the file. This, for example, the sentence is, this is a book. So this is one bigram. Is book is another bigram. Sorry, is A is another gram. A book is another gram. So you have to calculate bigrams from that whole text files. Calculate. And then you have that there are, for example, 70 bigrams available in that. For example, 70 bigrams are available in that text. And then you have to do what? Then you have to count the total number of words in that file. What is the total number of count? Maybe 200. Then do what? Calculate. Then you can calculate what is the probability of that first bigram. Then you will count in the text file. This is available how many times in the file? Maybe 5 times, maybe 15 times. And then what is the total number of bigrams? Maybe 50 in the whole file. So then that 7 divided by that 50, you have the probability for that first, this is. And similarly, the next bigram, count it, divide it with 70, and then you will have the probability for the next. And similarly, when you will type that one word in your mobile phone, at the same time, that prediction system is calculating the probability. He has that probability in his algorithm, in his program, that after this word, what is the probability of the different words? It will identify those words and it will give you the word with the highest probability after that word where you are typing. So that is the simple. So that model is just working with that approach, with this approach actually. Now moving forward. So these are the exercises from section 7.1 that you have to do. And then now section 7.2. What is probability distribution? So you have seen finite probability, you have seen complements, probability of complements of events, and then probability of union of events. And then now probability distribution. Distribution. Distribute this thing. If this room is whole space, then there are different events. Like, for example, you are the different events. We are the different events. Then the maximum probability for this whole space is 1. So from 0 to 1, that probability will be distributed to all these events. If there are n events, then the probability of one event is 1 over n. Generally, it can be different. For example, one event, I can give higher probability value to that event. I can give less probability to that event. Similarly, I can give 0 probability to that event. It depends on your models. Anyhow, probability distribution. If there are n possible outcomes, x1, x2, and xn, or you can say events, outcomes from the space, okay? If there are n possible outcomes, x1, x2, and xn, then there must be these 2 conditions. Then 2 conditions must be met. The first thing that if these are, for example, outcomes are events, then their probabilities would be from between 0 to 1. Probability of xi would be greater than or equal to 0, can be 0, or greater than 0, and less than or equal to 1. It would be between 0 and 1 for all the i's, for all the 1, 2, and up to n's. And the second thing is, when you have n outcomes, if you will sum up their probabilities, that would become 1. Probabilities of all those outcomes from I is equal to 1 to n, if you will sum up all events or outcomes, their probabilities, if you will sum up, that will be 1. Yeah, that is a fact if you are in the probability theory. And this P which we are using, we can now, here in these equations, this P which we are using for probability, now it is called probability distribution. If you have n events, then each event or outcome has its probability value. So those probability values are distributed among those n outcomes. So that is the concept of probability distribution. So what you have to keep in your mind, only two things. If there are n outcomes, their sum would be equal to 1, and their probability values individually would be between 0 and 1, nothing else. These are the two things. Now we are going to see this example 19. In this example, we have two questions. First one is, what probabilities should we assign to the outcomes H, where H is head, where H means head, and T is for tails, when a fair coin is flipped? When you flip a coin, what is the probability that head will come or the tail will come? That is one question. That is simple, you know that. There are two possibilities, so 1/2. From 2, head has the probability 1/2, tail has the probability 1/2. 2, the total space is 2 events, which is given. Probability of E is E divided by, and what are the 2 events? Head and tail. So probability of head is 1 among 2, 1 given 2. Probability of tail is 1 given 2. Now next is, what probabilities should be assigned to these outcomes? Outcomes are what? Heads and tails. When the coin is biased, when coin is not okay, there is something wrong with the coin. So when the coin is biased, so what probabilities should be assigned to these outcomes so that heads comes up twice as often as tails? So now there is something wrong with the coin, and if you will flip the coin, the head will come up twice or 2 times as compared to the tail. As compared to the tail, head will come 2 times more than the tail. If this is the biasness that you have done with the coin, then what is the probability of the head and the tail? This is the second question. First question is, what is the normal probability, which you know that probability of head and tail is 1/2. If the coin is biased, then the probability of head is 2 times the probability of the tail. Now it is biased. The coin is biased. And you know that what is total probability according to that equation? Probability of head, probability of tail should be equal to 1. This is the normal definition, equation. And then put the value of this. What is the probability of head according to that second question? 2 times the probability of tail. That would become 3 times, equal to 1 in that equation. Which means I can move this 3 here, 1/3. So probability of tail is 1/3. So here what you saying, in the space you have total number of events 3. You will flip the coin 3 times. 1, 2, 3. And the probability of tail is what? It will appear 1 time. And from those 3, probability of head will come now 2 times. You know that. What is remaining? 2. So probability head is now 2/3. So this is a simple question. Now, what is uniform distribution? So in probability distribution, the value of the probability among these outcomes may be different from each other. As you know that probability of tail is 1/3, but the probability of head is 2/3. So each event has different probabilities. Maybe, I'm using the word maybe, because of more often chances is that the probabilities will be different, because distributed. Probability 1 is distributed among all events. Uniform distribution. Uniform means something which will be like similar. So uniform distribution. In this distribution, you will have the probability 1/n to each event or element of S. Each event, for example, x1 will have 1/n, x2 will have 1/n, x3. So uniform. So uniform. Okay. Definition 2. In this definition, this is maybe due to literature, okay? Because it can happen that in some book, some person has given this definition, but it's also okay. This equation is saying that the probability according to this definition too, now you have the concept of space, you have the concept of event, but now in that event, you have many outcomes. This is which I told you in the beginning. That an event can have outcomes. An event can have sub-events, you can say. So now, according to this definition, in event E, we have the outcomes. Here, what are the outcomes here in this example? The head and the tail. And event is what? Just you can say the flipping of coin or anyhow. So the probability of event, this equation is saying something that now according to this definition, in event you have the outcomes. So the probability of event is equal to you will sum up the outcomes which are available in E. Here you can see small s belongs to E, which means that this outcome is this s is not space, okay? This s is for the previous definition of E. Here you can say, and this E is for the capital S, according to that previous understanding that we have. So anyhow, so this small s is the outcome which is available in the event. So now in the event, you have outcomes available. In one event, for example, in one event E, you have 5 different outcomes available. So we are calling those 5 outcomes S and only one event. And how you can calculate the probability of that event? By calculating the probability of each outcome and then sum it up. This is that equation is saying simply. probability of S1 plus probability of S2, you can say. Here S1 is not mentioned, but just for understanding. No, we know that probability of S1, probability plus probability of S2, plus probability of S3, plus probability of S4. So the probability of an event E is the sum of the probabilities of the outcomes in E. So that is what's written here in this equation. And it is being said here that if your E, if your event is infinite, will contain infinite outcomes, then you will do what? You will do again the same sum. But if it is an infinite, then you will make some formula and then apply that formula. It is written here convergent infinite series. Then this summation that you have, sigma S belongs to E probability of S, that will be convergent. Normally converge means if something is scattered before, but now they are focused on some one point, that is called that now those scattered form is now convergent on that point. That, for example, there are different outcomes or different points, and if lines are coming from that one, and if this is the point A here, they are coming from different positions and gathering it at one point. So that is called convergent on that point. So when you will have the infinite things, then you will make some formula and to calculate something. Now see this example. Suppose that a die is biased or loaded. Die again, that dice, that I don't know, what is the Arabic word? Huh? Nard. Okay. So nard for the Ludo, huh? So suppose that a die is biased. Now there is something wrong with the die. Okay, maybe you have done something wrong with the die because you are an expert of the Ludo game. So now suppose that a die is biased or loaded. Here loaded means maybe you have put some weight on one side, or maybe you have scratched some weight from that side, and then you will have. So suppose that die is biased. And the effect of that biasness is that 3 appears twice as often as each other number. That the number 3 in that die appears 2 times as compared to other 5 numbers. And all other 5 outcomes except this 3 are equally likely. And other 5 numbers except that 3, they have the equal chances to appear. Then question is, what is the probability that odd number appears? And question is something on other direction, not asking for the 3. What is the probability that an odd number appears when we roll the die? So you have to calculate the probability for the odd numbers for that die. And what is the odd numbers? 1, 3, and what is 5? So you have to calculate. So you have to consider this 3 also. You have to consider, so this is also some one outcome. And then you have to consider these 1, 3, and 5. So you have, if you have to, so for example, all 5 outcomes are equally likely. So you have that 5 number, that 5 numbers are those, and 3 appears twice. So actually you have 5 plus 2, 7 numbers. So actually you have 7 possibilities. 5 is Five numbers are the possibilities. And this 3 which is appearing twice as compared to other 5. So 5 plus 2, 7 possibilities. So from those 7 possibilities, so that is one thing. You can say your total spaces. Your total space. So now this is what, but we want to find the probability of odd numbers. And event is 1, 3, and 5. 1, 3, and 5. This is odd. We want to find the probability of that thing. Okay, that is the question. That is the event. And what is the space? Probability of one number, 2, 4, 5, and 6. We are not writing 3 here, okay? We are not writing 3 here. All these 5 numbers are equally likely. So total possibilities are 7. So all these are equally likely, which means they have 1 out of 7, which is written here. All these are equally likely. 1 out of 7. But this 3 has what? 2 out of 7. This is according to that situation. Now what? Probability of sum. Sum, according to that equation. You only have to sum up. You only have to sum up their probabilities 1, 3, and 5. We have the probability of 1. We have the probability of 5. We have the probability of 3. Just sum it up and you will have your answer. And then probability of E is what? Probability of 1, 3, and 5. 1 is 1 over 7, according to from these things. Probability of 3 is 2 by 7. And simply probability of 5 is from here 1 over 7. Add up. And then you have 4 by 7 is the probability for these odd numbers. Odd number will appear. And then you have another theorem. Read that definition by yourself. Moving forward. How much is left? Shukran. So this theorem 1 is not saying anything. When you have the E1, E2, and so on, infinite, you only, the probability of union of EIs, you have multiple events. You have to take, then what probability, you have to calculate probability of E1 plus E2 and so on. You have to sum, nothing else. Conditional probability, that is important. In the probability, conditional probability is again important. In the conditional probability, now you have 2 events, E and F. You have 2 events, E and F. With probability of F, this one. With probability of F greater than 0. So that would be given. Now, in conditional probability, E and F would be 2 events, and the probability of second event would be given to you. The probability of F greater than 0, it is mentioned here. Then the conditional probability of E given F. F is given. Okay. Then the conditional probability of E given F, you can represent it with probability of E given F. This is the sign for the given. Whenever this sign is, it means that this F is given and you have to calculate the probability of E. And this equation is equal to probability of E intersection F. You have to calculate the intersection. Then this is given. Probability of S is given. So this is the equation for the conditional probability. This is the equation for the conditional probability. Now, example 3. A bit string of length 4 is generated at random. Bit string length is 4. Generated at random. Randomly generated. So that each of the 16 bit strings of length 4. Bit string of length 4 will be generated randomly and you have to produce 16 times. 16 bit strings, okay? What is the meaning of this sentence? So you have the bit strings of length 4 with 4 bits. And you have to produce these bit strings 16 times. Second, third, fourth, fifth, up to 16 times. So that each of the 16 bit strings of length 4, 16 bit strings, you will produce 16 strings. And each of 16 is equally likely. And each string is equally likely. What is the probability that it contains at least 2 consecutive zeros? Consecutive. Musalsal, I think. Okay. So consecutive zeros. So 0 with 0. So in each 4-bit string, 0 will come with the 0. What is that probability? What is the probability that it will contain at least 2 consecutive zeros, given that its first bit is 0? This is given. This is F. This is F. Okay. Whatever will be given to you, that would be F. And 2 consecutive, I will have to find the probability, that is E. Given that its first bit is 0. So from those 16, if you have the 4 bits, first is 1, 2, 4, and 1, 2, 4, 8, and then it will become 4 bits. And from those 16, if first is for 0, other is for 1, for 2, for 3, for 4, convert it into binary, then you will have from 0 to 15, you will have those 16 bits with 4 bits. Then you can understand that given that its first bit is 0, so only 8 first 4, 8 are starting with 0. The rest, yeah, you can understand that. The first is 0, 0, 0 for 1, 0, 0, 0. Sorry, this is for 0, 1, and you can move on. And for example, when it will be 1, 3, 4, 8, when it will become 8, this is for 8, okay? Then the first bit is, afterward, the first bit is 1. So you have, Allah, Allah, Allah. My son. Anyhow. So given that its first bit is 0, so there are then only, out of this 16, only 8 bits are possible. 8 by 16 is 1 over 2. We will see that afterward. But you can just imagine in your... And there are... Anyhow, so what... We assume that 0 bits and 1 bits are equally likely. So in these, each 0 and 1 are equally likely. They have equal chances to appear. So what is E here? E is the event, bit string of length 4 contains at least 2 consecutive zeros. This is what I have said here. And what is F? F is the event that the first bit of the bit string of length 4 is 0. That is given here. You have to use this equation, so don't worry. So it is more easy as compared to the previous, the beginning questions. So the probability that a bit string of length 4 has at least 2 consecutive zeros, we have to, for that, we have to use that equation. So this is just a repetition. Leave it. So just write this equation by using this conditional probability. Write that equation. Probability of E given F, I will compute by using that thing. But I don't have this E intersection F. So that is first you have to calculate. E to intersection F. What is E? 2 consecutive zeros. And what is F? First bit is 0. Then what? You can write all those 8 bits and then you can understand. So E intersection F, you have to take these both conditions together. And then you can understand that Two consecutive zeros, this one or that one. And what was the other? Start with zero. F is start with zero. Starting with zero. And then what is that one? This is 2. This is 3. Or that is 3. That is 3. And then what? This is 4. Hmm? And this is 5. And this is 6. And this is 7. And then 8. This is, I don't need that. So here, what is E when two consecutive are 0? And what is F? Start with 0. So both are there, so I will consider. Both are there, I will consider. Two consecutive zeros, start with 0, consider. Two consecutive zeros, start with 0, consider. Two consecutive zeros, start with 0, consider. Okay. This is no two zeros, no two zeros, no two. Let's have a look now. So E intersection F is now what? 1, 2, 3, 4, 5. So these are those numbers. This is what here we have. So probability of E intersection F is what? Total is 16 bits. And I want this for these 5s. So 5 divided by 16. Now you have that probability for that one. And what is F? F is first bit is 0. First bit. And how many these are? 8. So that is 8 divided by 16, 1 over 2. Put it in the equation and you will have your answer. 5 over 8. 5 over 8. Moving next. How much left? Oh Lord. I am stopping and I will cover these 2 slides in the... Maybe we can take... Let's have a look. Let's have a look. 1, 2. Let's have a look. Maybe we can finish within the extra time. Example 4. Or maybe you can read it by yourself. It says, anyhow, what is the conditional probability that a family with 2 children has 2 boys? What is the conditional probability that a family with 2 children, there is a family with 2 children, and they will have 2 boys. 2 children, 2 boys, fully loaded. So what is the probability? Given that, so that is given they have at least 1 boy. So this is now F. Given they have at least 1 boy. So assume that each of the possibilities. So now assuming possibilities. So BB, both boys, boy, girl, girl, boy, and girl, girl. Between 2, so for those 2 you have these options, is equally likely. Where B represents a boy and G, okay, there's no read. Note that BG, boy, girl, represents a family with older boy and girl is coming after, so girl is younger. And when you have GB, girl is older. This is additional, extra information. The question is, what is the conditional probability? And maybe we have E and F here in this statement. So what is my E now? E is the event that family with 2 children has 2 boys. So this is what I said when I was reading that. This is E. And this given is something, at least have 1 boy. This is the F. F be the event that family with 2 children have at least 1 boy. This is F. So I have to calculate conditional probability. And if you know the equation of the conditional probability, then you know that you have to calculate this intersection and then you will go through. So what is E? E has the 2 children with 2 boys. BB, this is E. if you just write it in notational form. And this F with two children, at least one boy, this is the possibility. BB, BG, GB. And each pair has at least one boy. And what is intersection? When two boys and at least one boy both are existing, that is only possible here in this one pair. And what are the total probabilities? 4 possibilities. So probability of F, there are 3 possibilities, so 3/4. And probability of E intersection F, this is only one pair, 1/4. Put this in the equation, you will have your answer. Coming to the last slide. This is about independence. What is independence? This is also, maybe I can remove that topic because it is not, but it is a probability. Only the name is different. Some events are independent to each other. So this is now what you are going to see. So if event E and F are events independent, if we say E and F are independent, then there is one condition that should be met. And what is that condition? This one. Probability of that E intersection F would be their multiplication individually. Probability of E and probability of F individually. I'm going to this example 5 directly. Suppose E is the event. Now we have the E event, that a randomly generated bit string of length 4, same previous example, length 4, begins with 1 randomly generated bit string of length 4. So you have the bit string up to now only one bit string with length 4, begins 1. And F is the event that this bit string contains an even number of ones. Even number of ones. So a string which will have 4, which will have of length 4 bits. And the number of ones will be even. Not consecutive, even. Okay? Not consecutive, even. So that is our F. And what is the E? Randomly generated bit string. That will start with 1. Are E and F are independent? And the question is, E and F are independent or not? We have to find if the 16-bit strings of length 4 are equally like. Okay. Now the same question, 16 bits. And this E is what? It will start with 1. And F is what? It will contain even number of ones. And if you know this equation, are E and F and independent, then you can understand this is what you have to calculate. So there are 8 bits of length 4. So bits begin with 1 is E. And these are mentioned here. From these 16. From these 16. Here not all 16 are written. But here, so. And there are also 8 bits in which even number of ones are coming. Here it is, we have the F. From here we have the F. So from those 16 bits, we are writing in which you have the even number of ones. Even starting with 0. Even starting, because this is not, yes. Yeah, you can go if somebody has exam. This is the last slide. I'm going to end. Maybe it will take 1 minute, maybe. So this is the F. E is what? Starting from those 16 strings. The strings which are starting with 1 are written here. And what is F? In which the even number of ones is even. Either it can start with 0 or 1, no issue. So that's why from those 16 bits, I'm just writing. I'm not giving further explanation. And now you have the E and F. So what? Probability of E intersection F is equal to probability of E and probability of F. So you have to calculate probability of E individually and probability of F individually. So there are 16 bits. So probability of E and F would be E is what? Start with 1. Those are 8. 8 by 16. And probability of F is what? 1, 2, 3, 4, 5, 6, 7, 8. So these are also 8. So that's why it is written for both. Probability and E and F both are 8. So 8 by 16, 1 over 2. And their intersection means it will start with 1, and also contain even number of. So from these bits, then you can identify. From these bits. So from these bits, you can identify. It will start, which are also existing in this F. That would be your answer for that one. So probability of E of F is equal to how many these are? 4. 4 divided by 16, 1 over 4. So now probability of E intersection F, you have calculated 1 over 4. Can you write this probability as the product of 2 E and F? Yes, you can. 1 over 2, 1 over 2, which is equal to 1 over 4. So it means that probability of E is half and probability of F is half. So you have to solve this question like that. And this definition, read it by yourself. Here you have the definition for the pairwise independent and mutually independent. It is nothing else. For example, probability of EI intersection EJ, you can just write it as probability of EI and EJ, like that. Nothing else. And similarly for that one, nothing different. But the difference is that maybe it is going up to M times. And these are the exercise questions. And this is the end for the CO4. And next I will start with the CO5.